Salam sejahtera and good morning everyone. My name is Hani. It is a great pleasure to welcome all of you to our training today on the Low Carbon Building Checklist LCBC 2.0 web portal. And as you may recall, the LCBC was first implemented in June 2024 last year, and it was officially launched by our minister in August last year as well. So following that, we had the 6-month trial run, and we C40 and DBKL, we gathered valuable feedback from both internal teams and also from the public. And with all the feedback, we have now progressed into phase 2, where we transition from a manual Excel-based tool, Excel sheet, to a fully integrated web-based portal. And this upgrade is designed to make the assessment process more efficient. We definitely want to make it user-friendly and scalable for all stakeholders, ensuring smoother adoption and greater impact moving forward. And before we begin, I would like to take this opportunity to thank you, the DBKL team, especially the JPRB Secretariat, JKB, OSC team, JPPBB, and also the IDB team for their strong support and commitment in making this progress a success. And today's training session, we have been designed to follow all this agenda to basically to introduce participants to the LCBC web portal interface and also the functionality. We also want to provide the hands-on guidance for building information, input, and also assessment processes. Also demonstrate passive design evaluations technique within the digital framework to clarify administrative workflow and user role management. And the most importantly, to ensure that participants can independently and confidently utilize the system after today's training. And to guide us through this session, I am pleased to have the IEN and Cobler team with us, who will be leading and coordinating the training. And with that, I would like officially hand over the session to Gregis from the IEN and Cobler team. Thank you.
Thank you very much, Hani, and thanks for dialing in, everyone. Sorry for the little delay. I had to restart my laptop. So let me just show a few introductory slides before we get started. So 1 second here. I'll just share my screen. And we would also like you all to register for the project. So this is basically a training session for the low carbon building checklist version 2, which is via a web portal. And if you would just take a moment just to scan this QR code and register yourself. That would be great. Hi, Coxing. So Coxing will also help with the training today. And I also have my colleague, Simon, who is also assisting.
Hello.
Hi, Simon. So while you're registering yourselves, just to recap, we will be spending the morning until maximum 12:30 to take you through the LCBC web portal tool. And we'll start with an introduction, the objectives, and some video guidance. Then we'll have some admin and user role guidance. And that will be done by Coxing. And then we'll go to the building information training, basically the web portal, all the input that you need to give, and then review the results. So after each training, we'll have a Q&A session, so you can ask as we go along. Right. Oops. So, oops, I stopped the sharing, I can see. Let me just reshare it. Sorry about that. All right, so I think you should all have registered by now, and I think we get going. So, so I had a slide, but it was it disappeared. I had a bit of computer problems this morning. But anyway, I'll just go straight to the overview. Actually, maybe let me just go to this one. So just to recap the overall objective of this low carbon building checklist calculator, which is now an online portal. So first of all, it's the intent of DBKL to make this a mandatory submission for new buildings. We don't know the launch date yet, but it will be later this year. So that means in addition to all the other submissions you have to do for your building submissions, the KM, the BP, and the CCC, you will also have to go onto this online portal and do a carbon assessment of the building. And there'll be some thresholds for this submission. So this will be submitted by the PSP, the principal submitting person, typically an architect. And the portal will do a calculation immediately. We'll show you that later. It's actually an annual simulation, and it will tell you whether your building meets the threshold or whether it doesn't. So basically a pass or a fail. So in case you get a fail, that means the carbon footprint of your building is simply too high, and you have to go back and do a little bit of redesign. So you have to commit to improving the energy efficiency typically of the building, or maybe use less carbon intensive building materials. So we'll show you all of that. And this is aligned with the EECA, so the Energy Efficiency and Conservation Act, that came into effect of 1st of January of this year, launched by the Suruhanjaya Tenaga, the Malaysian Energy Commission. So this EECA applies to existing buildings, but we are using the same performance thresholds and basically applying to this application process. So it basically the same requirement of energy efficiency and therefore also carbon footprint will apply to new building submissions. So let me just give you an overview of the portal real quick. So we basically have some inputs, and these inputs will go into a online calculation. So this is behind the scenes. You won't see this, so you don't have to worry about that. Essentially, it goes into an Energy Plus building simulation engine, which is state of the art. And that one will do annual energy simulation with the Kuala Lumpur weather data. And then within a minute's time, you get the output. So it will basically calculate what is the operational energy and therefore also the carbon emissions from the building energy consumption. We'll also calculate the carbon emissions or the embodied carbon, you could say, from the building materials. And we'll also calculate the carbon emissions from the transportation. So this is the commuting transport to and from the buildings. And then there'll be a number of different thresholds and results presentation. But we'll show you all of that in the web portal itself. But this is sort of the overview. So, and why are we doing this? Well, Kuala Lumpur and C40 have basically, or the Kuala Lumpur itself has committed to become a zero carbon city by 2050. And C40 is working with DBKL to ensure that that happens. And of course, the emissions from the building stock of Kuala Lumpur plays a big role. And therefore it's important for new buildings being built that they are locked into a low carbon track. These requirements will likely also be launched for the retrofit of existing buildings, but that will be at a later stage. And just to show that it really works, so these are some measured data from Europe, specifically from Denmark. And here you can see how the energy consumption and therefore the carbon emissions of different buildings have been plotted into this graph. And once the building code for energy efficiency was introduced back in the 60s, and then it was revised gradually. Lately it has been every 5 years or so. You can see that the measured energy consumption and therefore carbon emissions of the building has really dropped a lot. So having mandatory thresholds for energy consumption and carbon can make a huge difference in going towards a low carbon society, which Kuala Lumpur has submitted to. So with no further ado, I propose that we go to the website. This is the address. But maybe before we do that, are there any questions? That doesn't seem to be the case. All right. Then let me just check the chat 1 second. There's no questions on the chat. All right, then we will proceed to the website. So maybe Hani, can you help put the link to the website in the chat as well? I can also do it, maybe. Whoops, sorry. So let's copy it in here. Okay, I'm putting the website link in the chat. So if you want to log in yourself on the site, feel free to do so. All right, so let me share the website. So I'll just change the screen sharing here. All right, so now you should see my screen and the opening page on the website. So we'll go in, and I already have an account, so I'll log into the dashboard, but if you're a new user to this website, you will have to create an account first. And that account will basically need an email verification. So you have to put in a valid email. And then once you click create account, you will get an email verification where you get a 6-digit number that you have to then type into the web portal. So I'll just skip that. There's oops. There's videos to show you how each of these steps are done, and I propose today we'll play those videos. So you look for this button up here where it says help and tutorials. So let's try to click that. And here you can see all the videos that you can play. So let's try to do that. Maybe we can take a simple one, which is the sign up one that I just talked about. So let me try to play this one. And we'll just also put in, whoops, subtitles. I think it is subtitles already for Malay because the videos are recorded in English. But in YouTube, if we click down here on CC, then you can get subtitles, and you can actually click it so it becomes Malay. So that's the default setting, auto-generated English to Malay. Okay, let's see how it goes. Sign up process. Can everyone hear what's being said on the video? Just checking.
It's a bit low.
It's a bit low. Okay. Let me see. This volume is a maximum. Okay. well, maybe you have to, it's maxed out on my end. Maybe you have to just turn up your volume on your end. But you can hear it and you can see the Malay subtitles, right, at the bottom?
Yes.
That's great. Okay, then let's try to play this video, and then we can have a Q&A after you watch this. This is quite a short one. If you don't have an account in LCBC web portal, you need to do so by clicking this button at the top right corner. Click on sign up. Put in your email address. Put in a strong password. And take note, it has to be at least 8 characters and contain uppercase, lowercase, a number, and a special character. Repeat that. Next. Put in your name, your phone number. And click next. Put in your company name. Put in your company number. Put in your PSP license number. This is for the principal submitting person. If you don't have one, it's okay. You can see there's no asterisks, so it's not a mandatory field. Then read through the terms and conditions, read through the privacy policy, tick mark both of them, and create an account. A one-time password will be sent to your email address, the one you entered. So once you go to your email, find that email, you type in that 6-digit number, and then you press submit, and then you create an account. Sign up. All right, great. So any questions to this? Oops. Any questions to the sign up procedure? Let me just check. There's no, let me just check the chat. I guess you can ask in the chat as well. There seems to be no questions. Yeah, I see on the volume it says too low. Were you able to hear the video, or is it much too low?
It's possible to hear if you turn up your volume yourself.
Okay.
But quite low.
Quite low. Okay. On my end, because I'm also playing the videos on the online, it was quite loud when I play it. So I think it's because of Zoom, somehow the volume gets lowered a bit. All right. Then let's go to the next video. Maybe before I do that, I'll just show you. So this was the office example I gave you here. The office example 2. So here you can see this is how the website, the portal looks like, and how you can navigate through. So you enter all this, and we have these 7 input windows here that I'll take you through one by one. So but you can, yeah, easily try it out yourself once you register, and you can have a look through the website on your own. So at the moment we are at the KM stage, and then once that has been submitted and approved by DBKL, then you can also enter your BP stage, and the same thing, submit it to DBKL, and once that's approved, you can get to the CCC stage. All right, so now we go to the first one, the building information, and again, you can click here and say watch tutorial if you have any doubt on how to enter the information. There's some explanatory text for each of the entries if you mouse over the I here. So that's also quite helpful, but I think we just watch the tutorial together and then we'll see if there's any questions. So let me click the tutorial. In this section, which is the first 7, we type in the basic building information. Also, you can see in the top bar here, we have the 3 stages. This is the KM stage. And we also have the BP stage and the CCC stage, but these are locked and cannot be entered because the building first has to pass the KM stage. So after submitting all of this and getting the KM stage approved by DBKL, the next stages will be unlocked and can be typed in. So let's go down and start the entry. We can see it's an office building as we typed in previously. And the first one is the gross floor area, excluding car park. And if you scroll down to the bottom of this page, there's a more detailed explanation about the gross floor area and what exclusions should be made to the area. So we go up here and put in the gross floor area. The next one is the percentage of that gross floor area that is non-air conditioned. So for this office building, it would be about 10%. The next one is the daylight coverage distance from the facade. So basically, we want to know how deep does the daylight reach into the building from the facade. So on a typical day, how many meters into the building can we assume that the electric lights can be switched off because there's enough daylight? So we put 3 meters in this case. We also have to enter the car park area above ground. And again, we can just scroll down to this basic cross section. So we have car park above ground and below ground. And later the building height, which should exclude the car park. So the car park above ground, we have 2,000. And the car park below ground, we have 1,500. The landscape area, here we are interested in the total landscape area that's planted on horizontal surfaces. So this can be on the ground, but it could also be on the podium or on the roof. So in this case, we have 550 square meters. Then we have the building height as shown in this illustration. So here we are only interested in the occupied levels. So in this case, this building is 28 meters high. And we click on next. All right. So let's close this one. And go back to the app, the portal. So any questions to this input? It seems like there's no questions, at least not on the chat. I'm not sure if people are allowed to speak, but I think it's maybe better to have it through the chat. And how's the Malay translation? I cannot. I hope Google is doing a good job, because first it has to try to understand what I'm saying and then translate it into Malay. Yeah, there's a question here on the LCBC requirement, and whether it's generally applicable to, whether it's not applicable to single residential buildings below 1,000 square meters at the moment. Yeah, that's correct. It's not applicable to those small residential buildings. All right, then we go and you'll see that, yeah, maybe we need to write the exact square meter requirement. So we'll take a note of that, so it's more clear. Thank you. Then we go to the next one. So here we go into the facade dimensions. And here we'll just watch this tutorial. So there's actually two tutorials here. We'll do the basic one first, and then once we have played the next one on the windows, I'll go back and play the second one so it makes more sense. So we start with the basic facade dimensions tutorial. Let's play it. Facade dimensions. In this section, we have to add the facades of the building. And to eat this process, we make it possible to upload a typical floor plan. Please note that the typical floor plan has to be an image file, so either JPEG or a. I'm just gonna pause it. For some reason I can't maximize this window. Is it playing at your end? That seems to be stalled at my end for some reason. Since maybe Simon, since you are also online.
Yeah.
Can you see if you can play this video? I don't know if you're.
Sure, let me just get it up.
Yeah, okay. Let me just see. Yeah, my laptop is giving me some problems this morning. Sorry about that. But I could hear the audio, but it was not moving, so that was a bit puzzling. Yeah, it's a little bit stalled. So I'll maybe stop sharing first.
I share my screen.
Yeah, great. Thank you, Simon. PNG file. You cannot upload CAD drawings or other building drawing software files yet. So
do you see my screen?
Yes. Do that.
Okay. Let me just make sure my sound is set up correctly. I don't normally play videos through Zoom.
Here is a floor plan. It's quite loud on my side. Of a somewhat complicated facility.
I'm not playing anything.
But we don't see the.
I think the sound comes from your end.
Oh. Oh yeah, true. Sorry, it came from my end. That's why I was so loud.
You hear this?
Oh, it's very low. But actually, I can probably play it now. If
Okay, I'll let you play then.
okay, sorry about that. Okay, I'll just share back my screen. Sorry about this little mishap. Okay. So let me play it. Facade Dimensions. Did you hear that?
Yes.
Great. In this section, we have to add the facades of the building. And to eat this process, we make it possible to upload a typical floor plan. Please note that the typical floor plan has to be an image file, so either JPEG or a PNG file. You cannot upload CAD drawings or other building drawing software in files yet. So we'll do that. Here is a floor plan of a somewhat complicated facade because it goes in and out like this. And to start tracing the facade, sorry, something happened. It seems to stop playing the video. Let me just you click there we go. On trace, start tracing. And it might be helpful just to zoom in a bit so you see the facade as big as possible on the screen. And you start in one corner. Often it's a good idea to make the first facade the main facade. For example, the one that's facing the street. So for this particular building, it's actually the facade over here on the left. So I'll start here on the bottom corner because we trace clockwise. And then you basically put the cross at each corner of the facade, one by one, like this. And you just keep going until the whole facade has been filled up or traced out, as demonstrated here. And when we get to the end, you click back the first point that you started with. So there's a marker here. So once you click on that, the whole facade has been mapped out, traced out, and it automatically labels the facades starting with main facade, F1, then F2, 3, and so on, all the way around. So in this case, we have 20 facades. You will also notice the north arrow at the top right here. So in this case, the main facade is actually turning west, facing west. So you go down here and adjust the angle. So we need a 90-degree rotation, and this was actually in the wrong direction. So I need to put minus 90, which is not possible. So then I'll just put 270. And that suits the purpose because now the north arrow is pointing pointing straight up, and my main facade is facing west. You also have to put in the building footprint area, excluding the car park of this representative floor. And in this case, there's actually an atrium in the center, but you include that atrium area. So the area of my footprint, as traced out here, is 1,500 square meters. And once you type that in, the length of each of the facades is automatically calculated. So in my case, it's pretty correct because each facade is just below 30 meters, and that's exactly what we have here. You can see if I put a bigger footprint, then the facade lengths are adjusted. So I'll revert back. Also, if you regret later that you want another facade to be your main facade, let's say facade 16 should be your main facade, then you can click there, and then that becomes the main facade. So now you can see it changed to here. But in our case, let's keep main facade safe, which is easier later on when you enter in the next section. And then we click next. All right. So, any questions to that? See. I see something in the chat. I'll just stop sharing here. Let's go to the chat. Okay. Do we need to upload each level? No, that's not necessary. So that's where we want you to upload a representative level. So let's say if you have an office tower, then you basically take one of the floors in the middle, in the center of that building, the one floor that you have the most of, which represents the building quite well. So you wouldn't typically take the ground floor. That might be a bit different, maybe a bit bigger. You take a floor that is representative or the most typical floor of the building. All right. Any other questions? That's not the case, it seems. So we will go to the next. Input window. So we go to the passive design for Windows. Click here. And then we'll watch this tutorial. Let's see if I can play it straight from the web portal. Passive design Windows. In this section, we need to enter the shading devices for the windows. So please refer to this diagram that shows the windows in blue and the different shading elements of the windows. We have horizontal overhangs above the window, and they can be offset a bit, so that means they are placed a bit higher than the upper edge of the window, which is shown here. We can also have vertical fins that are placed next to the window, and they will have some depth and will be spaced apart by a certain distance. So we have this table that shows all the 20 facades, and that's of course a lot of numbers to be typed in. So to make it easy, we allow you to take a typical facade, let's say it's a main facade, basically the top facade here. You type in the values and then you can click copy from main facade to all. So in this case, this building has a window to wall ratio of 0.4. So that means 40% of the windows of the facade consists of windows. The window width in this building is 1 meter. The window height is correct, it's 1.5, so we'll leave that be. Then we have the overhang of the horizontal shading. So the overhang is 1 meter. It has no offset because it is completely aligned with the upper edge of the window. But we have a side fin that is not so big, 0.2. And they are spaced 3 meters apart. So we'll copy that information to all the rest of the facades. So this is done, and this can save you a lot of typing. But then you can individually go in and change each of the facades. And if you don't remember what exactly was facade 2, you can always go back to facade dimensions, check back on the drawing, and for example, in this case, facade 2 to 5 didn't have any windows, so we can go back and enter that. So basically, we didn't have a window. For technical reasons, you are not allowed to put a 0 here, so therefore we just put in a small value. So you just have to put 0.01, which is basically very close to 0. So simulation wise, it's effectively a 0 window facade. And once that's 0, then all the rest doesn't really matter because there's no window to shade. And then you can do that along the same principles for the rest of the building. So once you're ready, once you have entered all that information, we click next. All right. So any questions to that?
Gregors, there is one question from Nabila.
Yes.
So, for Nabila Farhan asked, do we need to upload each level?
Yeah, we don't have to do so. Just the representative level that is typical for the building. So that's the answer, because it's a early stage submission, so there won't be too much detail anyway. So basically choose a level somewhere in the middle of your, let's say, office tower or residential tower, and upload that. All right. Then we will go back to the sharing. Let me just see here. Where is the window? 1 second. Just need to open the right. Here we go. All right, so let me share back the web portal. And that was the windows, but maybe here you ask yourselves, because here you can see there's only one type of window that you can type in. I mean, window to wall, but maybe you have 2 different kinds of windows. So I'll address that Actually, I'll go back and play one more video after we just put in the thermal properties for the windows. And then I'll show you how you can enter a facade that has two different window types. So let's go to the passive design input for the thermal properties of the facade. So we click here on Watch Tutorial. Passive design thermal properties. In this section, we have to put in the thermal properties of the walls and glass of each project facades. Once again, we have a big table with all the facades. And once again, we are allowed, we have this function that can copy down information from the main facade in line 1 to the rest of the facades, because quite often both windows and properties will be quite identical. So the first property to put in for the wall is the solar absorptivity. So this is basically how big a fraction of the sunlight is absorbed by the wall. And for this entry, we have put this color scale. So basically, if you have a pretty white facade, then you have a low number. And if you have a more dark surface, then you get closer to 1. So in this case, our building has a fairly white wall or light colored wall, so we put 0.4. The U value is basically how much heat goes through the wall. And for this, the lower value is good. That means it's an insulated wall, whereas a high number means it's not an insulated wall. So we'll put in 2, a U value of 2 here. These values would often be calculated separately. Then we go to the glass properties of the windows. And here again, we ask for the U value. So same thing, a low value means it insulates better than a high value. So in this case, we have high performance glazing. So we'll put in 1.5, which is a fairly good U value. And even more importantly, the shading coefficient of the glass. So how much of the solar heat is rejected, you could say, shaded by the window properties themselves. So a low number is higher performance glass, and a higher value is a lower performance glass. So in this case, we'll put in, have a fairly good glazing, so we'll put in 0.3. And then we copy that to all the rest of the facades. And we could say, for example, for the first 5 facades, maybe we have some pretty dark paneling on those next 5 facades. So we can go in and change them, and so on. So that should be quite straightforward. After you have filled in all those values, we go to the thermal properties of the roof skylight. And here we want to know how big a ratio of the roof is taken up by a skylight. So in this case, we have a skylight that takes up 15% of the roof area. So that's 0.15. It's a ratio. We also want to know the roof. Is it a light color or dark color roof? How much of the sun is being reflected? So the solar absorptivity, in this case, we have unfortunately a quite dark roof, 0.8. Also, what's the U value of the roof? We have put in some insulation, so 1.2. Sorry, 0.6. And also for the skylight, what's the U value of the skylight? 0.4 in this case, and what is the shading coefficient of the glass? We'll put that 0.6, and then we click next. All right. Good. Any questions to that? I see some activity on the chat. Let's see. Sorry, I'll just stop sharing here. Oh, we can't see your screen. Okay, that was maybe. Oh, you couldn't see the screen for this last? That was unfortunate. So is that correct? You didn't see the screen just now for the thermal properties of the facade?
We could see that one.
Oh, okay.
It was only during the orientation of the north arrow.
Ah, oh, okay. I see. All right. Thanks, Simon. Okay, so here we have a question. The 20 facades is auto-generated after we did the floor plan tracing, question mark. Yep, that's correct. So so the first facade you trace, that will be your main facade. And then the rest are auto-generated in a clockwise direction. And the other question is, and for roof skylight, how about if no skylight? Well, if there's no skylight, then you enter an area for the skylight of 0, or I think for technical reasons it has to be the 0.01, so like a very small skylight. So then, yeah, you basically don't have a skylight. All right. Great. Let's go to the next video. And here I'll just go back because here you can see we can only enter one glass property, but sometimes buildings have 2 different window types, maybe even 3. So how do we enter this correctly for the OTTV calculation, which is done automatically by the software? You'll see that later in the results analysis. So therefore, let me just go back to the facade dimensions. And this is where we had the 2 tutorials. So if you have multiple window types, I'll show you how that's done. So let me play this video. Special case number 1. What if the facade has 2 windows? I'll show you how to get around this by retracing the facade. So let's say the main facade of this building has 2 different window types. Because this software only allows you to type in 1 window type, then a smart way to get around this is to split the main facade into 2 facade segments. So let's say that there's approximately an equal amount of one and the other window type. So therefore we say, okay, let's retrace the building. And then we go halfway up on the facade. See, I made 1 point there. And then we retrace the building. It could be the same for all the big facades. Let's say there are 2 different window types on all of those facades. So then I make a midpoint on the facade trace on the big facades like this. And So now you can see the main facade is only the first half of the main facade, and then we have the second facade is now F2. Likewise, for the other big facades, it's split into two facades. So the rest we leave as it is. And therefore, when we go into the windows, we now have window type. 1 and 2 can be entered separately in F1 and F2. So let's leave F1 as it was before, but let's say the other window, maybe the window ratio is slightly different. And so the width is probably the same, but maybe the height is a bit different as well. Maybe the overhang is also different. Maybe there's no offset with that one, and so on. So this is possible to do it this way. It's a little bit of a workaround, but I think it's quite easy. And the same on the thermal. We go back, so we have the first window here as a U value of 2, the shading coefficient 2.5. Maybe the other glass is just a simple single glazed thing with a low performance glass. So this is a way to enter 2 different windows. It could also be 3 different windows, in which case you then split up the given facade in 3 facade segments. You just have to make sure to keep track of that and make sure you get the window to wall ratio correct. So it requires a little bit of side calculations on the side. But that's the concept. Thanks. All right. So, any questions to that? Let's just stop sharing. Let's see. So there's no questions. There's a lot of information to take in, I suppose. But the good thing is you can replay the videos. At your own leisure, and maybe I'll just insert all the video links as well in the chat at the end. So you can also access them without being logged in to the LCBC app or the LCBC web portal. All right, then we'll go back to the next inputs. So I'll share my screen again. So we have now entered the facades, the passive design, the thermal properties of the windows and the walls, and now we get into the active design menu. So this would often require a bit of input from the engineers, the mechanical and maybe electrical engineer. We've tried to make it as simple as possible. So the architects, the principal submitting persons can do it fairly easily. Let's watch the tutorial. Design systems. In this section, we have to enter the efficiency of the systems that use electricity in the building. So this is basically, first and foremost, the cooling system. And we have made this overview table of the energy efficiency of various cooling systems. It can also be useful just to scroll to the bottom and have a look at this more graphical overview, where we have the efficiency color-coded from poor efficiency, fair efficiency, good efficiency, and excellent efficiency.
So so there are different cooling systems. We have grouped them into basically 3 sections. One is called centralized chillers, and here they can actually range from poor all the way up to excellent. Then we have VRF systems, which can also have pretty big span. And then the last category of cooling systems are split unit systems, and they can't go very high on the efficiency scale. So there is this overview, and just for the record, the total cooling system efficiency, or the total system efficiency, TSE abbreviated, is both the cooling system, so that means the chiller and the pumps associated with that on the water side, but it's also the air side, so the air handling units, or the fan coil units, and so on. But it's quite easy to type in, because it's basically a multiple sort of a drop-down list where you can choose from these 10 different systems. So if you know you have a centralized system, and you know, in this case, let's say we want a water-cooled system with AHU, then you just choose that, and you can see on the efficiency side, it has a fair energy efficiency. So you are not allowed to type in any numbers. It will just choose sort of a medium number of efficiency, which is shown in this table. So in terms of kilowatts per ton refrigerant, it has a total system efficiency of about 1. If you use the COP, the coefficient of performance, then the total system efficiency is about 3.52. So the next one is the lighting power density. And here you again enter, here you can enter a number, and there's some guiding numbers up there. So we'll put 7 for that. How many watts of lighting power per square meter is installed in the building? On the electric side, we also have renewable energy, and we are interested in knowing what is the total area of solar panels installed on the roof. So in this case, we have 300 square meters of solar panels. Sometimes they can be a bit shaded, so you also have to indicate whether it's a very shaded solar panel, in which case we multiply by a factor of 0.5, so that means they only have half the yield of unshaded panels. Maybe it's slightly shaded, in which case it has 70% yield compared to an unshaded, or it's not shaded. So in this case, we just put slightly shaded. And it will calculate how many megawatt hours of electricity these panels will produce per year. And then click Next.
All right. So, any questions to that? Please put any questions in the chat box. This was, more engineering-wise with all the electricity consuming systems in the building, but we tried to make it as simple as possible. So there's a question here. For this system, is there any scoring that we need to achieve? The answer is no. But you will see later, once this input together with the facade input is fed into the annual simulation software, then we'll get the annual energy consumption and therefore also the annual carbon emissions of the building. And if the building exceeds the threshold, then that means it's too inefficient, and therefore you have to improve, go back and, for example, commit to using a more energy efficient cooling system, or using a more efficient lighting system, or maybe just commit to using more efficient, a higher performance glazing, and so on. So it's a completely performance-based approach, where it's what really counts is the annual energy consumption, and therefore the annual carbon emissions coming from the energy consumption of the building, as well as the carbon emissions from the building materials that is used to build the building. So this will become more clear as we go forward. I hope that answered the question. So let's go to the next section. I'll just share the screen again. So that was the active design systems. Now we go down to the embodied carbon. And let's play that tutorial.
Embodied carbon. In this section, we need to enter the structural system type, the wall system type, the roof system type, and the glazing system type. And this is in order to establish what is the embodied carbon of the building materials used for this building. We already know the rough quantity of building materials from the previous entries in the LCBC web portal. So here we just have to select what kind of structural system are we using from this list. In this case, we'll use reinforced concrete. You are also asked to enter what is the percentage of green concrete used in the structural system, in this case at 30%. For the wall system type, you also have to select what kind of wall system are we using. In this case, we put glass curtain wall. For the roof system type, we have to select from this list. In this case, we put a metal deck. And for the glazing system, we choose a double glazed low E type of glass. Next.
All right. So any questions to that? Please put it in the chat box. So basically, for each of these building materials, there is a carbon embodied carbon figure, and this will be then calculated behind the scenes. You'll see the actual numbers of each material selected in the simulation report. And that's going to be, yeah, so you'll see that later. All right, but there's no questions yet, so we will proceed to the next and final input. So let me share my screen. So this has to do with the transportation to and from the building. And this one is, yeah, you'll see in the tutorial, but a bit difficult to determine. So it will be fast to enter this because you will typically just go with the pre-entered values. Let's watch the tutorial.
Transportation. In this section, we seek to establish the CO2 emissions from commuting transport to and from the building. The section has a pre-filled table, which is based on an elaborate commuting survey done by DBKL. In the table, you can see the distance traveled per staff per day and how many percent of the staff do this, and what the associated greenhouse gas emissions are per kilometer traveled. If you are closer to a station than 200 meters or less, you are allowed to click yes here, and then you can actually change the data. Otherwise, you just leave it at no, and you will get the default values in this table, because it's difficult to know exactly the commuting habits. But let's say our building is close to a train station, you can actually go in and change values. And for example, on rail, if you're right next to a train station, it's fair to assume that maybe 35% commute by train. These percentages have to add up to 100. You can see now it's 130, so we have to reduce 30% from somewhere else. So let's take 20% out of the car travel, reduce it to 42, and maybe 10% out of the taxi or e-hailing. So now the percentages sum up to 100%, and we have shifted to more low carbon commute. And we're done. So at this stage, we can click on the simulate and compare button. And for that to work, you have to check that we have a green tick mark at all the categories here. If any information is missing and it's not green, then you have to go back and fill in that information before we can go on and click simulate. Before you click simulate and compare, it's a good idea to just click save draft as well. So that. Once it's saved, then we click on simulate and compare.
All right. So, any questions to that? I suppose not. Here the transport mode detail is compulsory. Yes, it has to be entered, but as you saw just now, you can just go with the pre-filled data that was established through the DBKL survey that was done in 2020 for about almost 3,000 of their staff. We included the transportation because half of the carbon emissions of Kuala Lumpur actually come from transportation. So it's quite high carbon emissions that come from transport. And of course, it relates to some degree to buildings because a lot of people drive to and from the office. And what if the city could reward people for having better public transport connections and or showering facilities, so you could either walk, cycle, or run to work. Of course, this is not going to happen overnight, but we are including the transportation, as you'll see in the results, where you can also see it's a fairly high emission factor. And therefore, it's something that needs to be part of the conversation. But to begin with, there will be no mandatory requirements for meeting certain transportation thresholds. It's just there for information. It's the same. I can see there's a question here about residential buildings. Yes, it's the same for residential buildings. So you might live in a zero energy residential building somewhere in the KL suburbs, but if you drive 30 kilometers every day to work, there's a big carbon footprint associated with that. So so you can sort of be, by right, you should be punished for that in a carbon footprint sense. But as mentioned just now, at the moment, this commuting transport carbon footprint is just for information, and DBKL will decide whether later on whether to put some thresholds for that. There's a question here. More distance means will between more carbon emissions or less. Yeah, so I think what you mean is the further you travel, the more carbon emissions. Yes, exactly. So just compare it to your monthly petrol bill. So if you have to transport yourself very far and fill up the car regularly, then that translates directly into carbon emissions, more carbon emissions. So, but as mentioned, it's not a mandatory item at the moment. It's more like for information, almost like a placeholder. Maybe for the next version of the LCBC tool, there could be some threshold put in, but not yet. But you are sort of put on notice that this might be coming. I can also mention that the listed companies in Kuala Lumpur now have to do these commuting surveys where they have to assess the carbon emissions of their staff to and from the office. So there'll be a lot of this data sort of being collected at the moment, and we'll see if we can get hold of that to supplement the existing survey done by DBKL to get a bit more detail on this. All right, then we go to the results part. Let me just share my screen. And let's see if I click simulate and compare. So I'll just do that straight from here. And here's the watch the simulation tutorial. So that should be a pretty easy one because you just have to press this button down here. But let's play it with Malay subtitles.
Simulation. To run the simulation, you click the button at the bottom of the screen, like this. And the portal feeds all the data that was entered into an online Energy Plus simulation. So this is a state-of-the-art simulation software that does hour-by-hour simulations for the whole year. And it's fed with the Kuala Lumpur weather data. So it's specific to Kuala Lumpur. And here are the results.
All right, so I'll just ask if there were any questions to that short video. I think not too much. But as mentioned, I'll just mention a little bit more about the Energy Plus simulation. So, so Energy Plus is, I would say, the state-of-the-art simulation, building simulation engine that's been around for almost 25 years. And it's actually developed in the US, and it's developed free of charge for the world to use, and they update it twice a year. The only thing is there's no user interface, so therefore it's a bit hard to use as a normal person, and that's why we've done some scripting behind the scene. So basically, all the input you have given, we take that input in and then feed it in the right format through some computer scripting to the software. The simulation is done with the Kuala Lumpur weather data, and then the results, the annual energy consumption results, are then fed back into the web portal, and that's what we're going to see now. All right, so let's go to that. I'll share my screen again. Whoops. Sorry, that was the wrong screen. Here. So let me share my screen. Sorry. Here we go. All right, so we ran the energy simulation, and let me just see, am I on the right screen here? Simulate and compare. Maybe sorry, I have to do it on my side as well to get to the results page. So it's actually quite impressive how fast it can run, because of course we are building a fairly simplified building, but as you saw, we actually have 20 facades with all kinds of shading and different windows and so on. So here we go. This is the results. So once we have the results, then you can click here and say watch the results tutorial. So let's do that. Let's watch this video.
Results. The results page has 4 different sections. The first one has to do with electricity consumption and the BEI. And here it shows graphically the energy consumption of the submitted building. In this case, it's 118. And this is somewhat lower than the threshold. And that's a threshold set by the EECA. It also shows how this building performs compared to an average office building, national average for office buildings in Malaysia. And here we are also a bit lower. You can scroll down and see some other values, but we'll do that later. Next, we go to an annual energy consumption breakdown. So if, let's say, your building does not comply, you need to resubmit and change your inputs and basically make the building more energy efficient and lower carbon, maybe also on the material side. So this breakdown of the annual energy consumption is quite useful because it shows you where is it that I'm consuming all this energy. So of course the cooling system is a big one. The equipment in the building also, so that's a plug load, also accounts for quite a lot. We have the lighting, various miscellaneous loads, outdoor lighting, and the car park consumption. If we go to the carbon performance, this is really the main page that gives an overview of the 2 thresholds that your submission has to meet. And the first one is operational carbon, so how much energy consumption and therefore carbon emissions from energy consumption does your building emit? And this is well below the threshold and also of an average, somewhat lower than an average building. So this is basically a mirror image of the first graph we saw under the building energy intensity, except we have converted electricity consumption into CO2 emissions. The other one is on embodied carbon, and here the building also meets the threshold, but it's a little bit higher than an average building, as you can see. So in this case, this building would pass because it meets both the threshold of the operational carbon and of the embodied carbon. On the transport carbon emissions, there is no threshold yet, but you can see it's actually a very high emission. And DBKL will likely in the future also impose a threshold, maybe not for new buildings, but for existing buildings. But this is yet to be announced. For now, it's here as a placeholder and for information that this is actually a significant carbon emission. At the far right here, on the daylight analysis, shows you the floor plan of the building and how far the daylight reaches into the building. In this case, the daylight reach is shown by the blue color, and we put a 3-meter deep daylight reach. So this is that 3-meter deep daylight perimeter zone that is automatically calculated and shown. And it also states in the middle of the floor plan that this is a 3-meter daylit perimeter, and that adds up to about 27% daylight coverage. If we scroll down, and this is the same for all those 4 panes we just saw, it will give some key data. For example, some of the peak demands, both for electricity and for cooling, are shown. And this is useful for the engineers to be able to size up electric systems. What is the maximum draw of electricity expected? So in this case, it's about 839 kilowatts. For the cooling system, we also get these data out from the annual energy simulation, and we can see that the maximum draw is about 350 ton. So this again would be helpful for the mechanical engineers to size up the cooling system, so we avoid major oversizing. We also have the maximum cooling demand, and that is the absolute value measured over the year. But these two, often you don't design for that because that would be like just a short period of time, and it's okay for most buildings to just be 1 or half a degree warmer for those brief periods of time during the year. So often you would design for the other two, the maximum cooling demand just above. If we scroll down, the software also calculates the OTTV, the overall thermal transfer value. In this case, it's 29, and that's much lower than the required maximum value of 50. It also calculates the RTTV, the roof thermal transfer value, in this case 44, also within the threshold. And it calculates the renewable energy production. This table shows the simulation assumptions and the source of the different assumptions. So the receptacle load is the same as the equipment load that we saw on the graph. We have the miscellaneous loads, which is a fixed value. We have the lift consumption. We have facade lighting. So a lot of these are taken out of the ASHRAE standard down here, which is the American code. We also have a CO2 set point for fresh air. We have a people density and people diversity. So these are both assumed to be fairly high. We have 10 square meters per pax and no diversity. We have a weekly operation of the aircon system of about 52 hours per week. So this is the standard value used by GBI. And we have the thresholds for BEI or the EUI, the building energy intensity or the energy use index, which is essentially the same, set by the EECA. And we have the grid pollution factor of the TNB, Peninsula Malaysia in this case, and this is reported by Malaysia. We also have the embodied carbon factors for different building materials. This will likely be updated a bit, so it becomes more based on Malaysian figures. And here we have the electricity grid emission factors for Peninsula Malaysia, for Sarawak and Sabah, and just for reference what it is in the EU. The last thing under the results is to export a energy report, which can be done by clicking this button and downloading the raw files, which is basically those input files that were sent to the Energy Plus online simulations. Both of these can be downloaded and reviewed.
All right. So this was the crux of the software in a way on the results side, and there was a lot of information. So if you want me to go back and show some of the results in a sort of more live demo, let me know. But are there any questions to this? So we have a question here. If by the end of the system threshold exceed, can PSP modify back all the keyed in data? The answer to that is yes, because you haven't submitted yet, right? So you run the simulation, you see the results, and if your threshold is exceeded, that means basically if you decide to submit that, DBKL will ask you to resubmit. So basically it's better for you just to go back and see how can you improve the energy efficiency and lower the carbon footprint of your submission to be within the threshold. And I can actually demo that. Let me demo that shortly. Let me just read here what you say here. Isn't it better for each item to have a threshold so the PSP can focus on specific items that need to be improved? Yeah, that to me that's the old way of doing it. So it's much more. I mean, either you have a performance-based approach, which we do here. So it's actually the sum of whatever goes on in the building, as long as the overall figure is within the threshold for the whole building, then you're okay. The old way of doing it is to basically put a requirement for each of the systems. So the lighting can't be higher than that, the U values can't be higher than that, and so on. I think the way forward is to have this overall performance-based approach, which also gives more flexibility to the designers. So they are sort of less restricted because, okay, maybe they want some bigger windows certain places, which strictly might not comply with this more sort of individually threshold approach. But because the overall performance of the building still falls within the threshold, then it's okay. So therefore your degrees of freedom in designing the building is actually higher, because you can sort of, it's almost like a trade-off, right? You have maybe slightly poorer glazing, but then you put more insulation in the wall, or you have a more efficient air conditioning system, and then you can still meet the threshold. Also, in terms of CO2 emissions, Mother Nature doesn't care whether the CO2 comes from different parts. It's the overall figure that matters. So I hope that answers the question. But let me go back and just share the, we can do a variation. So let me just share my screen. So here, these are the results we just saw, right? So here we are within, if I actually go to the key table, which is on the carbon performance, right? So we have two thresholds that have to be met, the embodied carbon and the operational carbon. So here we are actually doing quite well. So if we go back to the form and let's say we go down, let's go on the Windows side. And let's say we have a much higher window to wall ratio everywhere. We copy that down. And we also, maybe we remove some of the shading. So we don't have any shading of the windows, right? I put it to 0 here. And instead of having high performance like low E glazing, we use basically a float glass. And we can also change the walls to be quite dark everywhere. So, and maybe not so insulated. So we put here 4 maybe. So we copy that down to all. And let's say we also have a, let's say we go with a split unit design for the aircon, which was the poor performing one. Okay. So now we've made some changes. We save this as a draft. You can see we still have the green tick marks everywhere. So we can go and simulate. So we rerun the simulation. And let's see how that affects the energy consumption of the building. So now it's running all that new information in the Energy Plus. And now you can see this definitely shot up the energy consumption. Before we were somewhere down here. And now we are, getting closer to the threshold. So before we were more efficient than an average building, which is this stippled line. Now we are actually higher than an average building. It also writes it out here, 15% higher, but we are still 22% lower than the threshold. So if we go on the carbon performance here, you can see we are still in the clear, but we are starting to get close to critical levels. Yeah, and on that note, I would also say the threshold set by the EECA is not that strict. So I would expect most buildings, or it's not too difficult to comply at the moment. But of course, that threshold over time will most likely keep coming down, just like we saw on that slide I showed you from Denmark, where the threshold is basically close to 0 now. So that's also what could be expected in Malaysia. But as a sort of early stage, first launch, it's fairly easy to comply. Okay, some questions here on the chat. Let's see. So let's go to the bottom here. So there's sorry, there's no additional questions. I already addressed it. So is there any particular result that anyone wants to know more about? Or any input? otherwise, this concludes the LCBC dashboard or LCBC web portal training, and I think Coxing will take over and explain a bit about the whole structure, navigation of the system. Maybe I'll just show here. So now we have done the simulation. We meet the threshold. We are happy with the results, right? You can review everything here. And once you are happy with that, then you submit. You press this blue button and submit for the KM phase. So let's do that. And it just double confirms that you're actually ready to submit, because once you submit, it goes to DBKL. So you cannot retract it. So we say yes, submit for approval. And it goes into the DBKL system. And here you can see now it appears here on your dashboard, and it's for the KM phase and is under review. So then you need to sit back and wait for DBKL to approve it. And you can also review all your other submissions. Here we just sort of typed in different buildings. But basically it will show all the projects you have. And so it's an easy way to track the ongoing submissions from your office as a PSP. Coxing, you want to take over from here and do a little bit of sharing on the...
Yeah, Gregors. Yep, sure. Can you hear me?
Yeah, we hear you fine. I'll stop my sharing.
Okay. So, Gregors has explained a lot about the PSP side of the dashboard. So my name is Coxin and I'm from Cobler. We are the ones that created this web app. So right now I'm going to jump to the admin portion of the dashboards. So this is primarily used by the internal admin team from DBKL to approve the projects that's being submitted. So let me share my screen right now. Okay, do you guys see my screen? Can everyone see my screen?
Yes.
Okay. All right. So this is the admin dashboard. This will be reserved for the few that is going to be part of this process of approving the LCBC submissions from DBKL itself. This dashboard is pretty simple. It just shows you a few key items, mainly the how many reviews that is needed to be done by the user, as well as how many submissions that is already being submitted. So this is the overview dashboard for the admin itself. So it's pretty self-explanatory, right? And then it's just a summarized view of what you can do within the admin portal, right? So Gregors has submitted an example project to the admin. So in order to view that, you can click on this pending review as an admin. Okay, and just now Gregors has submitted this project, which is called Office Example 02. Now, as an admin, if you would like to approve this project, you can click on this button right here. It will show you the form that is being filled in, that is being submitted by the user. So from here, you can click on the Simulate and Compare button, okay, to review what has been submitted. Now, as an admin, you only need to care about a few criteria, which is noted on the top. So if the submission by the user is below threshold, it will show the compliant badge up on top. So you can go through these charts one by one to see if each of these are compliant. So the only two things that you need to care about is the BEI to make sure that it's under threshold, and as well as the carbon performance side of things to make sure that the operational and embodied carbon is under threshold. Okay, the rest should be, it's not needed to approve. Okay, so as this example project, we can see that these two items are compliant. So from here on, you can just select to approve this phase. Okay, so if I click on this button, it means the button will, it means the project will be approved and be reflected on Gregor's account to say that, hey, the KM stage has been approved. You can now move to the next stage. And if for any reason there is a submission that doesn't meet the threshold, we can click on this reject KM phase button. And for example, let's say we found out that the BEI section is not within threshold. We can type in the reason why this project is being rejected. So for example, I'll type in here, BEI section does not meet threshold requirements. Okay, and then once you click on the reject button, it will actually reflect this on Gregor's side as well as show the reason why this is being rejected. Okay, Gregor, can you work with me on this to showcase to the user on how it will look like on the. So for this one, I'll maybe approve it first.
Yes.
Okay, so right now I've approved the submission from Gregor's. I'll let Gregor show what it looks like on his side of things.
Yep, so I'll log back in on my screen. So here we see my screen. And let's
refresh the page. That is
refresh the page, okay. Let's see here.
okay. So you can see it has at once from the KM stage to the BP stage. So now Office example 02 is waiting for submissions from the user for BP stage. Okay. So Greg, can you kindly go into the same project and modify your value to make it exceed the threshold?
Yes, let me see here. I go into the, so now, yeah, we are on the BP stage because the KM is approved, right?
Yep.
Let's see, then we go into active design systems. Let me put this one up pretty high. Okay, let's see if that does the trick. Maybe I just make sure it exceeds. This is like a little bit unrealistic. Okay, it only allows me to go up to 30. Okay, and then we go to, I guess we can just save the draft. Always good to save before you run the simulation and re-simulate. Yeah. You see my screen? So if we go on the carbon performance, you can see here the building exceeds the threshold. And it says non-compliant up here. So if you press submit, then DBKL will reject this submission.
Gregor, could you maybe submit it and I'll show the admin side on how to reject this.
So I submit this. All right. So I press the blue button, submit for approval. And now it's on the BP side. It asks me, yeah.
Okay.
All right.
So maybe I'll share my screen again to see what it looks like, to show what it looks like on the admin. All right. So this is how it looks like on the admin side. So right now I have the same submission from Gregors, but right now the phase is a BP. Right. So what I'll do is I'll jump into the same project. I'll click on simulate and compare, and I've noticed that the BEI section and the carbon performance are not compliant at all. So I'll just reject, saying that the BEI section and carbon performance section is not compliant and exceeds the threshold. Okay, so once I do that, I type in the reason. I can click on reject. Okay, so right now, Gregors, maybe I'll just hand it over to you again to showcase how it looks like on your side.
Yes. So I'll just refresh, I suppose, my screen. Let's see. Yeah. So here we go. I got a reply in record time from DBKL.
Yep.
Saying,
if you can click on the project.
Yeah, saying needs revision here, and I click on the project. And yeah, this is rejected, action required. And then the reason that was just typed in, that the BEI section and carbon performance section is not compliant and exceeds the threshold. So it suggests I run through and address the feedback points and resubmit for my for admin review. So in this case, if you remember, we had one of the poorest cooling systems. You can see poor split unit. So let me try to go with a centralized system with HUs. I put save draft. And then I simulate and see if that brings me into the green, into the clear. So actually, this is pretty good because the review is in a way done automatically. So when you submit, you can already see if it's compliant or not. So here it says compliant, and that meant that the project, if I just go to the carbon performance here, from being above the threshold, now we have dropped below the threshold. So this building should be compliant, and I'll submit that one, right, Coxing?
Yes, yes.
So I'll resubmit so this is a resubmission of the BP phase. So we submit that one, and I hand it back over to Coxing.
Yep. All right. So that concludes the approval process for the admin. So just to summarize it up, you only need to the admin needs to look at the form, check the two graphs to make sure that both are compliant, and then they can either approve or reject with a reason, and it will be reflected on the PSP dashboard. Okay, so that is the main component of the admin dashboard. Now, there are a few admin items that you can also do in the admin dashboard, which I will share right now. So one of it is that approval of users, user management. So by default right now, any users that signs up to this platform will be automatically approved. Okay, so one thing that you can do if you notice that if the admin notice that there is a PSP that is not legit, or is doesn't submit forms correctly, or is violating any rules or any terms and conditions, you can come in here and then click on this button. So clicking on this button will signify or disable the user, and that user cannot log into this platform anymore once that is done. Okay. And one last thing is that the admin can also choose to publicize any projects that they deem is worth showing. So for example, right now, say if I want to showcase this building right here, I can click on this as an admin. I think it's not working right now. But so let me just refresh the page. Okay, so you can see right now, this icon has been, it is green right now, and it means that this project is public. So the results on the simulation page, as well as the form inputs, are available for the public to view. So I will show you where this shows up as an admin. So if you go back to this main homepage, it will show up in this tab called Featured Buildings. I think it's not working right now. But yeah, eventually, this approved public project will show up on this Featured Buildings tab for to be able to be viewed by the public itself. Okay. And I think that's about it, because I think I approved a public project that is that was an old one. So any new submissions that is approved recently, and if I choose to make it public, it will show up on the Featured Buildings tab.
What if you try to publish the example, the one just below?
Oh, okay.
Would that work?
Yeah, I think this one, because this one we are still working on it.
Okay.
Because I think it's not fully completed yet. It will only show up once the building has gone through all KM, BP, and CCC phases.
Ah, okay.
Yep. Okay. Okay. I think the one last thing that you can do is more of a content management type of system, whereby you can just take a look at all the buildings that is currently available within this platform itself. So you can just navigate to this building registry tab, and you can see all of the submissions that has been submitted to this platform or created. Okay, that is all for the admin dashboard side of things. It should be simple enough to be used by the admin to approve any projects and to manage users and to make showcase any worthy projects that to the public itself. Any questions from the participants on the admin dashboard?
I don't see any questions on the chat. So I think, yeah, feel free to type in some questions or ask them directly. I think this more or less concludes our training session. So there's one question here. The question is, LCBC is for all approval stages? And the answer is yes. So for KM, BP, and CCC. Any other questions? All right, no more questions. As mentioned, I don't think we have a specific date yet, but the DBKL intends to make this mandatory pretty soon, later this year. and I believe the mayor will also be doing an official launch of the LCBC web portal sometime in September. I don't know if the date
In
has been set.
October. Tentatively in October.
October, okay, great. All right, so if there are no more questions, I think we can conclude the training session. And let me just paste in all the
There's one more question.
the video links. Oh, okay, sorry. Chat. Oh yeah, here. For the PSPs, need to be sustainable consultant, or can it be architect or developer? Yeah, you don't need to be a sustainability consultant. So if there is a sustainability consultant on the project, you can put that in the form in the beginning, but it's not a mandatory field. So it's just for information. So this is really more directed at the PSPs, the principal submitting persons. So maybe as a final thing before we log off, I'll just give you the direct link to all the training videos on YouTube. And here are all the links. So if you want to copy that out for easy reference, you can do that before we end the meeting.
Hi, Gregors. Sorry to jump in. Maybe we can remind all the participants to register their name and details so that we could share all the link and we can send it to their email.
Yep, that's also a possibility. So if you haven't registered already, please scan this link, and we'll also send you all those links I just sent on the chat.
Gregors, is there any link that they could also provide the feedback on the training as well? Or they can just maybe share their feedback on the chat box. It should be fine as well, since we are recording the training. We really welcome and your feedback for all the participants so that we can improve the training. And also, as you know, that from all your feedback that we gathered previously during the training, this is the result from all the feedback, which is we basically develop the checklist from the Excel sheet to the web portal. So we are really appreciate if you could share some of your feedback, so a better improvement. Thank you.
Yeah, that would be great. Just to recap, the version 1 of the LCBC was a spreadsheet, and the overwhelming feedback was that it was too complicated to use, and also that it should be online. So that's what we have striven for this web portal. and we hope you found it fairly user-friendly and more simplified. And we hope those videos we shared also help to clarify any questions you might have. But I think we should probably add a sort of feedback or Q&A button on the portal, because I'm sure there will be other questions, and we can sort of have an FAQ. We can develop an FAQ list where we answer any questions that probably will arise. But I think it was quite positive that we didn't have so much questions during the training. So I think it should be pretty clear, but we would love to hear from you. And sorry about the low volume on the videos. I'm not really sure why that was the case, but if you play the links above, it's basically full volume, and there should be no problem in hearing it. So volume is okay. Okay, that's great. Even on the videos? That's good. I can see Coxing has also just shared a Google form in the chat. So if you click on that link, we would love to hear your feedback in a more structured way, maybe, than just putting it in the box here, but either way is fine.
I think if there is no feedback, then I think we can end the session, Gregis.
Yep.
Yeah, okay.
Let's do that.
Yeah, before we end the training, I would like to thank you everyone for joining the session, the training session. And again, I would like to thanks to all the DBKL team and also the external stakeholders today that joining for this session, especially again to JPRB Secretariat. I've seen Encik Nick here, Encik Zamizi, and the rest of the DBKL team. We really want to assist you to make sure that this training will help you in the future. We wanted you to become the champion as well. But if there is any feedback, please feel free to use the Google form. Provide us the feedback so that we can do it better. And then we hope that today training will be very benefit to all of you. So I would like to end the session. Terima kasih semua. And then
Ani, sorry.
Yeah.
We have
Okay.
one more question from Nabila
Okay.
Farhan. Maybe Gregor or consultant can reply.
So the one like the PSP account, right?
Yes.
I see
Okay.
Coxing has just replied, actually. He says, yes, one project per account.
Okay. Account. Yeah. For Nabila, if you have more question, please reach out to us or from your feedback, the feedback form, then they could reply to all your question. I think that can be done. Okay. Okay, without any delay, I would like to end the session. Thank you and terima kasih semua.
Thank you.
Terima kasih. Thank you very much.
Thank you.
Thank you very much.